This question's in a few different parts. The first part just says to find du dx and dv dx. So this is read the derivative of u with respect to x. Means let's look at the first piece. The derivative of u with respect to x, going to use the power rule here, is 4x cubed. dv dx is the derivative of v with respect to x. Here I have a bracket and a power, so I need to use the chain rule. So I go the derivative of the outside, 5 lots of 2x minus 1 to the 4th, times the derivative of the inside, which is just 2. That gives me 10 lots of 2x minus 1 to the power 4. The next piece says to use the product rule and the results that we've just got to show that if this was our function, which is just those two previous pieces multiplied by together, then the derivative would be equal to this particular result over here. So basically we know that the product rule says that y dash will be the first times the derivative of the second, which we already had from before. It was 10 2x minus 1 to the 4 plus the second term times the derivative of the first. And we'll see that if we just write this term first, we have in that one step shown that it's what was asked in the question. Part C says then to take out a common factor, and then they're actually telling us the factor. Factorising can be difficult. So they're saying to take out the factor of 2x cubed, 2x minus 1 to the power 4. So here is my derivative. I need to take out this out of both terms. So my y dash will become taking out 2x cubed and 2x minus 1 to the 4th. So I'm going to grab a different colour. And just actually, I'm going to cross out these pieces from each of these terms. 2x minus 1 to the 4th would be 4 of these, which would leave just one of them. 2x minus 1 to the 4th would be all of those, so they're gone. The 2x cubed, 2 out of that would leave 2, but all of the x cubed is gone. 2 out of this would leave 5, and I'm going to take 3 of those, and that would just leave me with 1. So what I end up with is, what I'm left with is 2 lots of 2x minus 1 here. And in the last term I'm left with just 5x. So if I tidy up that last square bracket, I'll see I've got 4x plus 5x is 9x and minus 2. So that is my derivative fully factorised. The last bit says, hence find the x coordinates of the points on the curve where the tangent is horizontal. These words come up a lot in questions. What this means is the tangent is horizontal, which would mean, if we just draw a quick sketch here, here would be a tangent. What we want to find is a place where the tangent is in fact horizontal, which is in this direction here. when the tangent is horizontal, the gradient of this particular tangent would be 0. So we want to find the x-coordinates of where the curve that we started with has a tangent that is horizontal, that is where the derivative equals 0. Now we've got the derivative, I'm just going to rewrite that. The derivative is 2x cubed times 2x minus 1 to the 4th times 9x minus 2. We want to find out where this equals 0. So we set the derivative equal to 0, and now we need to solve for x. Well, here we have 3 components that are being multiplied together to give an answer of 0. So in this case, this will only happen when one of these individual components is equal to 0. So we have 3 possible answers in this case. 2x cubed equals 0, which is where x equals 0. Or the second piece, which is 2x minus 1 equals 0, which is where x is a half. We have 9x minus 2 equals 0, which is where x equals 2/9. These are our x-coordinates where the tangent was horizontal, which means it has a gradient of 0.